In this video, I will talk about the rotation of a flywheel. So we are given a flywheel. A flywheel is simply a heavy spinning disc, and it is rotating counterclockwise, and it starts from the rest and sweeps out an angle of 65 radian in 15 seconds. Now we need to find out what is the average speed, the angular speed of the flywheel, the direction of the angular speed, the tangential speed at different locations. So let's start with this one. As the flywheel is starting from rest, its initial angular speed is 0. And it says that it sweeps out an angle of 65 radian. So the angle that it has rotated is 65 radian. At the time it takes is 15 seconds. From this information we'll calculate the average angular speed. So what is the average angular speed? It is the change in angle divided by the change in time. This is simply like calculating the average linear speed. How do you calculate the average linear speed? The change in distance divided by change in time. So the distance here is equal to the angle or equivalent to the angle, and the time is exactly the same thing. So if you know the calculate average speed in linear motion, then you simply have to change the delta x by the delta theta. So x is now theta, and that's it. Then you will get the angular speed. This change in theta means final angle minus initial angle and a final time minus initial time. The final time is the final angle is 65 radian. All the time this angle has to be in radian. Do not change it to degree. Whenever you use the equation, it has to be in radian. So 65 radian, this is 0. This is 0 because it is starting from rest, or we choose that as our reference angle. So theta, this is 15 seconds and the initial time is 0 again. So 4.33 radian per second is the average angular speed. Now, how do you calculate or find out the direction of the angular velocity? In order to do that, we have to use a rule called the right hand thumb rule or right hand curl rule. So in this case, what we do, we curl our finger in the direction of motion, in the direction of rotation, and then our thumb points out the direction of the rotation, or the direction of the angular speed. Again, fingers curl is in the direction of rotation and thumb points in the direction of angular velocity. So for example, in this case, this one is rotating counterclockwise, so our finger will curl in this direction and the thumb will point out in the above the direction. That means the angular speed is vertically upward. That's what it says here. Or I would say angular speed, angular velocity is vertically upward. And now we'll calculate the tangential speed. So what is the difference between the angular velocity or tangential velocity or tangential speed? Here I'm interchanging, sometimes using the speed and the velocity, but as far as the motion is one dimension, it doesn't matter. So the tangential speed is the speed at one particular location. So, and the direction is tangent to that point. So if I need to find out the tangential velocity, so this will be the direction of the tangential velocity. And how do I calculate the magnitude? So there is a formula for doing that. So the tangential speed the tangential speed here, I'm calling speed because we are not concerned about the direction. So the tangential speed is simply equal to r times omega. Remember the two things. The omega, the angular speed at any point, is exactly the same because each point makes out one complete rotation exactly in the same time. Each point here makes out one complete rotation exactly in the same time. So the angular speed is same for all the points, but the angular velocity is different. For example, this point sweeps out more distance compared to this point here. Exactly in the same time, this one has traveled more distance. That means the linear velocity at this point is greater than at this point, or the tangential velocity of this point is greater compared to this point. Why? Because this point has traveled more distance in the same amount of time if we compare to this point. Or in other words, the tangential speed is the radius dependent. Or at a greater distance from the flywheel, we have more tangential speed, or omega. The v1 now at the different location, at 5 centimeter v1, I'm calling that as a v1, will be r1 times omega. The radius is 5 centimeter and I'm changing into the meter. And omega, as I mentioned, omega is constant. Omega is not changing. The angular speed is the same for each point. It doesn't matter where you take, the angular speed is exactly the same, which is 4.33. I think it should be 4.33. So if you do the math, 4.33 times 5 exponential minus 2, what you get is 0.22. So that's the angular speed, or sorry, the tangential speed at 5 centimeter. And again, the same way, if you calculate, what you get is the angular speed would be 0.44 or 43. I think this would be 43 here. Okay, so this is how we calculate the tangential speed and the angular velocity. Remember, the angular velocity is not the position dependent, but the tangential speed is the position dependent. So this is it from the rotation of a flywheel lecture. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.